Math 13 students, 8.1, finding a test statistic. All right, so we have 8.1, the test statistic. All right, so I'm going to remind people, we've looked at it before in the past, the test statistic is a mix of sample data and claims from the null hypothesis. Here this semester we focus on, at least in chapter 8, on the test statistic for a test of a population proportion claim, that is the Z distribution, P hat minus P, PQ all over N, and then we'll take the square root of all of that. And again, I'm going to point out that this is a mix. P hat and N come to us from our sample. P and Q come to us from the claim. If we have a claim about a population mean, I use the T distribution. X bar minus mu, all divided by S over the square root of the sample size. And again, a mix. In fact, this one I'll highlight here because it is really, truly an important notion. See, sample data there. And then mu there. And again, that comes to us from our null hypothesis. There is a third one, chi-square. This is a, looks like an X, but it's another Greek letter. This is the one we use if we have a claim about a population variance or standard deviation. We won't use this one this semester, but it does appear in 8.1, so I will throw it in. Now, we have a couple of examples. For our first example, we have a claim, and this is very, very basic. It's a population proportion claim. Some population has a claimed p-value of 43%. We have some sample data. And we're going to see if the data support the claim or not. And to do that, we're going to need that test statistic. Now, for the test statistic over here, there's a couple of things I need. I need my p-hat. 51 over 100. I will need decimal presentation here, no percentages per se. If p is equal to 0.43, Q is equal to 0.57. Remember, the two have to sum to 1. Now I've got everything I need to plug into my formula. So in it goes, Z equals, and then upstairs we have the 0.51 minus 0.43. Downstairs, 0.43 times 0.57 all over 100, and that will be within a square root. Let me bring my calculator over here. The calculation is a little bit more involved than some of the others we've seen. There's no super big issue regarding the order of operations, but I do want to take a look at it. So let me put it right there. So we have 0.51 minus 0.43. There's my numerator. I'm going to divide that by, I'll pick up my square root. And now within the square root, everything goes in very, very nicely. So 0.43 times 0.57, there's the P and Q from the null hypothesis, divided by the 100. I can just go ahead and hit enter, and I've got a z-score of 1.616. So there is the test statistic for this claim and this data set. All right, let me run through a second example. Goodbye. This one will be a claim about a population mean. So now I have a claim that the mean, whatever it might be, is less than 75. I'm not sure what we're measuring. Maybe speeds on our freeway. I have data that may support or not that claim. X bar equals 71 miles per hour. S equals 4 miles per hour, and N equals 45. So let's make this one about miles per hour. And I can go ahead now and literally jump right into the formula. So the t-score, 71 minus 75, that's in the numerator. The denominator here is truly more involved. 4 over the square root of 45. So let's go ahead and run through those key strips because they are more involved. Here's my calculator. Get rid of him. I'll handle the numerator first. 71 minus 75. Negative 4, not surprising. Now I'll divide that by, and this is where I truly need my grouping symbols. Open. 4 divided by. Now I'm within the square root. You can see that the arrow is within the radical. I'll scroll over, and now I'm outside of that, and I can close off the denominator. So now it'll take the negative 4 and divide it by 4 divided by the square root of the sample size. So negative 6.708. All right, now let's talk a little bit about how we actually use that. As I mentioned before, usually pictures work very nicely to illustrate this fact. We're using the t-distribution. There's a 0 there. We have a critical value somewhere in there. And since it's a left-tailed test, this area in here is the alpha, the level of significance. Now, I plot my test statistic, and depending on where that lands, I'll go with either the null or the alternative hypothesis. If it happens to land in that rejection region, I'll go with the alternative hypothesis. On the other hand, if the test statistic does not land in that rejection region, I'll keep the alternative, the null hypothesis 0 there. So there we go. I hope that helps. I'll run through a couple more examples as we get through this material. Thank you and goodbye.